And our first presenter is going to be Dr. Philipe Moriel. Philipe, of course, started out in Brazil, and then he made a trip to the University of Wyoming and finally landed at the University of Florida for his PhD in ruminant nutrition. He was first at North Carolina State University before coming to ONA in 2016. He researches nutrition strategies to improve reproduction, health status, and post-weaning management of cattle, all in the effort to improve cow-calf profitability in our subtropical environments. Let's also not forget about the wonderful body condition scoring training that is housed on his ONA website page, because I send people to it all the time. So we'll turn it over to you, and you can give us your information.
All right, so thank you everyone for joining us. Thank you for people here present today. So my name is Philipe Moriel. I'm an associate professor here at the center. And today, what I thought about is just to briefly mention some of the effects of heat stress in grazing cattle. Okay, what are some of the unique aspects about heat stress in grazing cattle? And then I'm going to show you some of our efforts that we have done in the past couple of years and some ongoing studies. Trying to address these issues that we currently facing. Okay, so heat stress in beef cattle, for the heat stress in the beef industry, not only in beef but swine, dairy, and beef cattle, for example, leads to about $1.2 billion annual losses. And the last estimate was done in 2010. So pretty sure it's much higher than that right now. And that reason for that is because it affects pretty much every metric of animal performance. So reproduction, immunity, growth, all of that is impacted by the heat stress, decreasing the performance of those animals and decreasing their efficiency. So we need to develop strategies, okay, to try to alleviate some of that problem. Not just genetics, right? Not just selecting for animals that are more thermotolerant. We need management. We need nutrition to complement those efforts. Even animals that are thermotolerant, they also suffer with the effects of heat stress. So briefly, what happens to an animal when it's going through heat stress? Okay, I'm not going to spend too much time on it. I have a lot of information in proceedings, so you guys can read it at a later time. So usually when the animal starts to experience heat stress, he's going to change first its behavior. He's going to seek shade. He's going to try to seek more water. Okay, he's going to decrease physical activity, trying to prevent the rise in body temperature. If that doesn't work, he's going to have to do something else. Then he's going to rely on increasing respiration rate, trying to dissipate a lot of that heat through the breath. If that doesn't work and body temperature continues to rise, that's when you're going to have a cascade of physiological and molecular changes in the animals, leading to decreasing growth, reproduction, and immunity, right? So what else happens to these animals? Recently, our colleagues at the Animal Science Department, working with dairy cattle, they also found out that heat stress, when it happens during gestation, it actually impairs the performance of the offspring. They're lighter at birth, they're lighter at weaning, they don't grow as much after weaning. They also have a poorer immune response. And okay, they also have lower milk production for the first 2 lactations, right, as mature cow. And more interestingly, it also that affects is not just in the daughter, it also happens in the granddaughter of these cows. So it's a transgenerational effect. And right, unfortunately, we don't know that in beef cattle. We don't have that information. But clearly, this is a problem not just for the immediate performance of the animals, but it has consequences through the next generations. Now, another thing that they found out is that the effects of heat stress changes with age. Right? So for example, calves that are born from cows that experience heat stress, when those calves are exposed to heat stress, they didn't handle very well. They were not able to maintain their body temperature very well if they were born from heat stress cows. But as a mature cow, those animals, they did better. So somehow the effects of heat stress changes throughout the life of these animals. And this is in dairy cattle. There are some evidence in other species. And unfortunately, we do not have that in beef cattle yet. And this is something we're working on. Now, what about the challenges in the grazing system? Okay, unfortunately, a lot of the knowledge that we have right now on heat stress effects in beef cattle was done in feedlot systems with Bos Taurus animals. Okay, so a lot of that information, unfortunately, does not apply to grazing animals with Boscinicus genetic influence like we have, right? Because of the differences in breed, how they respond to management, and also differences in management, grazing versus feedlot. And also in a grazing scenario, there's limited opportunity for us to alleviate heat stress except for management and nutrition, right? It's not, we don't have as many options that you would see in a feedlot system. So it's a much more challenging scenario that we'll hopefully will address in this presentation. So this is a picture that shows a clear scenario that everybody has every year, right? This is our replacement heifers. This is around September. Okay, you have flooded pastures, really hot, a lot of mosquito, decreases the gain of those heifers substantially, right? Sometimes 50%. But we all know that it's hot, but how hot it is when we put into numbers. So one way to put into numbers is to use this thermal humidity index, which is what we call THI. It's an equation that accounts for the effects of temperature and humidity combined, okay? And then when you have the temperature and the humidity combined, you can have this index. So the blue line is the average THI here at ONA from August all the way to November. The black line is the minimum THI that we had on that specific day, okay? The coldest time of the day. And then the green line is the maximum THI that we have on that day, right? Now, these red lines here that I just put on the top of it are the categories. So when the THI is below 70, we consider the animal to be thermoneutral. He's not experiencing heat stress. When it's between 74 and 77, that's when we consider heat stress. And then above 77, it's severe heat stress, okay? High concern for these animals. So as you guys can see, the average THI all the way from August to November is most of the time above the heat stress levels. And you guys can see that even in November, for several hours of the day, those animals reach a THI levels that is considered severe. In fact, if you calculate for the entire year, those animals experience heat stress for at least 4 hours of the day from 8 months of the year, right here in Florida. So it's a very long chronic exposure to heat stress. And then we're going to look at what are the impacts of that. The problem with that is being so long and so severe is that it corresponds to very critical moments for beef cattle production. Right? So for example, late gestation of first calf counts, late gestation of mature counts, calving around October, November. It also corresponds to weaning calves and shipping calves in July or August, and developing heifers, okay? So the most critical production stages that we have in the state of Florida, unfortunately, are negatively impacted by the effects of heat stress. So what are we doing to try to solve that problem? So the first study that I'm going to show you is this strategy called Stairstep Strategy. It's nothing new, okay? It has been done in other species successfully. The idea is that instead of you making those heifers gain on a constant plane of nutrition, right? Let's say, for example, a pound or a pound and a half a day. What you do, you slow down their growth at the beginning, and then you push them at the end, right? And so what happens when you do this is two scenarios. One, they will either achieve the same final body weight, but they will save about 10 to 15% on feed. Okay, so you're more efficient in terms of feed costs, or they actually will end up being heavier and spend the same amount of feed. So either scenario, you're being more efficient. You're either growing more or you're saving on feed. Now, this strategy we wanted to implement here in Florida, try to help deal with the heat stress. So for example, in our scenario, we have heifers weaned here in July. Okay, so for the hottest time of the year, we're going to supplement them with a little bit less of supplement. So every time we provide supplementation to those animals, we cause fermentation in the rumen, and that increases the body temperature. So by decreasing the amount of supplementation, our idea was that we're going to help those animals deal with the heat stress. And then whenever it's more, the temperature starts to decrease, right, the second half of the study, that's when we're going to push them, right? And then we're going to cause this compensatory gain. Those heifers will actually do better. Okay, so this study was done for 2 years. It was funded by the Florida Cattlemen Enhancement Board, so I appreciate their support. So we had, like I said, 2 treatments. Heifers that were supplemented about 1.5% of their body weight for 100 days, like constant plane of nutrition. And then you have these stair-step heifers that were provided supplementation about 1% for the first day. And then we double that amount on the second 50-day period, all right? So at the end of the day, after 100 days, they consume the same amount of feed. And then after 100 days, we synchronize those heifers and we assign them to bulls, AI, those heifers, everybody managed exactly the same. So what happens to their performance? Well, it turned out that it worked very well and it happened exactly what we thought. Okay, when we supplemented heifers at 1% of their body weight, their intravaginal temperatures was reduced significantly during the hottest hours of the day compared to those supplemented 1.5. But even though they were supplemented with about 30% less feed, they still managed to gain the same amount compared to those on the control group. That means that those heifers that are in the control group, eating about 1.5% of their body weight, a lot of that feed is just being, let's say, wasted with dealing with the heat stress instead of being put towards growth. Now, the second half of that study, when it's much cooler, okay, we don't see any differences in intravaginal temperatures of those heifers. Now, those heifers that were supplemented at 2%, they significantly increased their average daily gain compared to the control. A lot of that is because of the compensatory gain that I told you at the beginning, but part of that is also because now it's much cooler and the extra amount of feed is not leading to higher body temperatures. All right. Now, so when you look in the entire 100-day period, those heifers that did consume supplement, let me show you here. Here. So those heifers that were in Stairstep Strategy, overall, they had a much greater average daily gain compared to the control. They spend the same amount of feed. So feed cost did not increase, but we boosted their average daily gain. So at the start of the breeding season, they were about 18 pounds heavier compared to the control. Now, that advantage in the body weight did not do much to their puberty attainment. No differences in the percentage of heifers that were reached puberty by the start of the breeding season. But look at the final pregnancy rates. It's about 10% units higher if they were in this stair-step strategy. So we were able to increase growth and reproductive performance, all right, without increasing feed costs using this strategy. So it worked very well. It's very promising. From now on, we're going to try to do variations of this study, but it does show that through management and nutrition, we can help those animals deal with the heat stress and increase their performance overall. Now, what are we doing about some of the knowledge gap that I told you at the beginning? Okay, so I'm going to show you two studies that we began, one in May and one in July, right? The idea now is to use nutrition, right? Some feed additives, for example, or management to alleviate heat stress and promote their performance. And one of the key questions that we have is about the effects during gestation. So for these first studies that we're doing, management-wise, we're using the excess of shade or not, using artificial shade. Okay, and the only reason that we're doing that is because we have a large area without shade, and so it's easy for us to use artificial shade and provide a uniform amount of shade across pastures. Okay, but of course, in a natural, commercial situation, if you have the natural shade or the artificial shade, the animals will tend to go to the natural shade. Okay, this is just one method that we're using to help us design the study. Now, what are we doing with that? The first study. So this one started in May. Okay, these are pregnant heifers that they're going to start calving around September, okay, October, and breeding season started in January. So what we did in May, we assigned those heifers to 2 treatments, okay? Half of them received access to shade and half of them did not. And then within each group, we assigned them to receive a feed additive or no feed additive. That specific feed additive is called Omnigen. It's a supplement that is being used in dairy cattle, and it has decreased their body temperature, like very successfully. So we're trying to use management and nutrition again, alone or in combination to try to help them. The idea that here, the question is, if we alleviate heat stress, either through management or nutrition, are we gonna have short-term impacts on the calves? So in January, we're gonna early wean those calves. We're gonna put them in a feedlot. We're gonna challenge those steers. We're gonna look at feed efficiency, how their immune response happens, body temperature, all of that. Okay, so is there any short-term carryover effect of those animals on those offspring if they were managed differently during gestation? Now, I don't have all the data yet. We started in May, so obviously the calves are being born right now. So I can tell you that the feed additive so far hasn't done much. Okay, but we're gonna look in. We just began the study, so we're gonna continue collecting more data. But you already can see a huge impact of the access to shade. Okay, so for example, respiration rate. This is one indicator of heat stress. Okay, one way that they can help them deal with the heat stress. If they don't have shade, you have about 30 to 40% greater respiration rates. That consumes a lot of energy, okay? And that helps the animals try to dissipate the heat. So those animals that don't have shade, they're really trying to get rid of that extra heat. But even though their respiration rate is higher, much higher, they still were not able to prevent the rise in body temperature. So it's about 0.5 degrees Celsius higher when they don't have shade, which is about 1.2 units in Fahrenheit, right? It's a lot. So for example, normal body temperature of a cattle is around 100 to 102.5 Fahrenheit. The control group with the shade have a body temperature of 103. So even though we had shade, they're already higher than what it should be. Now the animals without shade is over 104. It's really, really hot to those animals. Now, obviously, that leads to changes in their behavior, like I told you at the beginning. So what you guys can see is that by 5 o'clock, those animals that had access to shade, because they have a lower body temperature, they feel more comfortable eating. So they start grazing much sooner. And all of that combined explains why those animals that had access to shade, they're able to maintain body condition score, where those animals that don't have access to shade lost it in just about 40 days. Okay, so we're going to continue that data until January. And most likely these differences are going to continue all the way to January. Right? And then we're going to look again what's going to happen to the calves. Now, this study here, we're really excited because it was recently awarded by USDA NIFA grant. It's a very long-term study. It's about 5 years. And this study in particular will answer the question of what are the long-term impacts on the offspring performance? Okay, if they are born from cows that experience heat stress or not, are we helping those animals when they're exposed to heat stress, or are we actually making it worse? Okay, so what we're doing is we have about 160 cows that in July, after weaning their calves, half of them are assigned to shade, half of them assigned to no shade. Okay, and they go like that all the way to calving. After they calved, everybody's treated exactly the same all the way to weaning in July. Then in July, half of the offspring from each group is going to be assigned shade or no shade. And again, we're going to expose them to the same stress that their mothers were exposed. The idea here is like, are we going to have the same effects as in dairy, which if they're born from cows that experience heat stress, they're going to perform poorer, like much worse? Or are we actually helping them? Are they going to do better when in this same type of environment if they are exposed to heat stress during gestation? So we're very excited. There's a lot of things that we're going to measure here. Transcriptomics, gene expression, metabolites, microbiome. There's a lot of things. We're really excited. Long-term project. And all of them will address a significant knowledge gap that we have right now. It's very unique. Haven't done anywhere in the world so far. So we're pretty proud of it. Okay. So with that, I would like to thank all the students, all the staff for helping all of those studies. And you guys can see my email there, even if you don't have any questions right now, and my phone number, the center phone number, please just let us know and I'll be glad to entertain any questions.